Today, we will learn about how do we verify trigonometric equations. Now, in our previous lesson, we saw that we can rewrite, if we want to simplify any kind of trig expression or equation, what we have to do is try to rewrite everything in terms of sine and cosine. So we're still going to use that same idea, but now we're going to extend it, and we're not just going to rewrite expressions, but we're actually going to verify equations now. So there's going to be two strategies that we're going to follow here. The first strategy is that we're going to try and rewrite everything in terms of sine and cosine. And when we talk about equations, we have two sides. We're going to choose the hardest side in order for us to rewrite that side to make it look like the other side. In other words, the main idea here is that we're going to rewrite the hardest side in terms of sine and cosine to verify trigonometric equations. So let's get started here. Now let's try to verify the following function. So we have this function. We want to show that tangent of alpha divided by secant of alpha equals sine of alpha. So like it was mentioned, the main idea, you have two sides. Let's choose the one that looks the hardest. So it seems like the left one seems the hardest. So let's try to rewrite the left side in terms of sine and cosine, and we want to match it to the right side. So let's look. Tangent, I know that tangent, I can rewrite tangent as sine over cosine. So instead of writing tangent, I can write sine over cosine. So instead of writing tangent, I'm going to write sine over cosine. And we're still going to divide it by, we're going to divide it by something else, secant. But I know that secant, that's equal to 1 over cosine. So instead of writing secant, I can write 1 over cosine. Oops. 1 over cosine. And that is equal to the right side. All we're doing is you're just gonna choose one side, and we're gonna just modify that one side. You cannot modify both sides. You choose one and make it look like the right side. So now we have this. It looks a little bit messier, but what do you know about dividing by fractions? I know that when you have a numerator and you're dividing by a fraction, that's the same as multiplying by the reciprocal. So now we have sine of alpha divided by cosine of alpha. Instead of dividing, I can change that to multiplication, and I'm going to multiply by the reciprocal of the denominator, which is going to be cosine of alpha divided by 1, because the reciprocal of 1 over cosine is cosine over 1, and that is still equal to the right side. But what do you notice about the cosines here? Notice that the cosines, they cancel out. And what do we have now? We have that sine is equal to sine. The left side equals to the right side, so we're done. Let's try one more example here. Now, we are going to try and verify that the left side is equal to the right side. I notice that the left side looks the most hardest to work with, so that's the side that we're going to be choosing to modify. So let's see. Cotangent. Is there a way for me to write cotangent in terms of sine and cosine? So notice that cotangent we can rewrite it as cosine over sine. So let's rewrite that. Instead of saying cotangent, I can write cosine over sine, still divided by cosecant. I notice that cosecant, I can rewrite it as 1 over sine. And that is still equal to the left side, which is cosine. So again, when you're dividing by a fraction, that's the same as multiplying by the reciprocal. So now we're going to have cosine divided by sine. And we can apply that keep, change, change. Instead of dividing, I can multiply. And I can multiply by the reciprocal of the denominator. So the reciprocal of 1 over sine is just sine over 1. And that is still equal to the right side. But what do you notice about the signs here? The signs will cancel out. So now we know that we have cosine over 1, which is just cosine. So now we end up that cosine is equal to cosine. So we're done. Let's show one more example here. Oh, actually. So let's see. We're just going to apply the same idea. Is there a way for me to rewrite the left side in terms of sine and cosine? Well, notice that the first term, cosine, it's already in terms of sine and cosine. So I'm just going to rewrite it. Cosine of x times secant. But notice that secant, I can rewrite secant as 1 over cosine. So 1 over cosine. The right side, we don't touch it at all. What do you notice about the cosines here? It will cancel out. And here, we end up with 1 divided by 1, which is true. So we're done here. Last example. Let's look at example 4 here. Let's make some space. Notice that the strategy here is try to write everything in terms of sine and cosine. So let's see. Tangent. Let's do some coloring here. Tangent. I can rewrite tangent as sine over cosine. Times cosecant. Cosecant, I can rewrite it as 1 over sine. And cosine, well, it's just cosine, so we're okay. Let's just do cosine over 1, if that helps. The right side, we don't change it at all. So see if anything cancels out. I notice that this sine is going to cancel out with this sine. This cosine is going to cancel out with this cosine. So now we have 1 over 1, which is just 1. So on the left side, we have 1 over 1 equals to 1. And that is basically saying 1 equals to 1, which is true. So this is how you simplify trigonometric equations. Again, the strategy here is to choose the hardest side. Once you identify the hardest side, try to rewrite everything in terms of sine and cosine using the basic trig identities that you have here and make a match like the other side. So now, here's another example. All right. I thought that was the entrance ticket. All right. So let's actually simplify this then. Let me bring here. Okay, so now we're done, right? Let's do example 5 now. So let's see. Sine. Well, same strategy here. Which side looks the hardest? Well, I see that the hardest side is on the left side. So let's try to modify that. Try to rewrite everything in terms of sine and cosine. Sine, it's already terms on sine, so I'm just going to rewrite that. So now we have a plus. Cosine, it's already cosine, so we don't change it at all. Times cotangent. Is there a way for me to rewrite cotangent? Notice that cotangent is cosine over sine here. So let's, instead of writing cotangent, I'm going to write cosine over sine. Cosine of x over sine of x equals to the right side. Now, even though I said to change everything in terms of sine and cosine, notice that cosecant you can rewrite as 1 over sine, but we're just modifying one side. If you started modifying the left side, you don't touch the right side, or vice versa. So I'm going to leave the right side as cosecant. All right, so now what do we have here? What do we have here? So the strategy here is to make sure, try to simplify. Notice that here we're multiplying. So let's rewrite our expression as just sine of x plus, you can put this over 1 if that helps. They're multiplying, you don't necessarily need to have the same denominator. So now we're going to have cosine times cosine. So that's cosine square over sine of x. The right side, we have not done anything to it. So now, remembering that if you're going to be adding two fractions, we can put this over 1 if that helps. If we're going to be adding two fractions, they need to have the same denominator. I notice that the denominator on one of the fractions is sine, so I need to make the other denominator to be sine as well. So we can multiply here. Well, sine of x, top and bottom. Sine of x. Sine of x. Multiplied sine of x, top and bottom. I didn't like the way that looks, so let me rewrite that. Let's see if I can move this. Yes, let me make some space. All right, excellent. So like I said, let's try to multiply sine, top and bottom. So now essentially what we have here is, why are we allowed to multiply sine over sine? Because sine over sine is just 1. So essentially you're just multiplying by 1. Or you're multiplying by a smart 1. Because if I do that, they're going to have the same denominators. That's the reason why you can multiply this. So now we have sine times sine, so that becomes sine square over sine plus the second one, we have not done anything to it, over sine equals cosecant. Notice on the left side, we have the same denominators, so now we can add. So now we're going to have sine square plus cosine square over sine, because they have the same denominator, so we can do that. And that is equal to cosecant. But remember our Pythagorean identity. There's a Pythagorean identity that says that sine square plus cosine square, that is equals to 1. If you see sine square plus cosine square, you can substitute it with the 1, which is exactly what we have here. So now this sine square plus cosine square, this expression, I can just substitute it with a 1. So now we have 1 over sine of x equals cosecant of x. But essentially, 1 over sine, according to our graph here, 1 over sine, that's equals to cosecant. So this left side, 1 over sine, I can substitute it with the cosecant. Now the left side matches the right side, so we're good. Now here's your entrance ticket. Try to verify the following trigonometric functions, or equations, I will say.